Well, hello, everybody. Welcome to McDonald Observatory. This is our program about eclipses, and we have a funny name for it. We're calling it Eclipses in the Heart of Texas. We got all confused about songs. Anyway, my name's Judy Meyer. I live and work here at McDonald Observatory, and I am so happy to be here with you. I am here with my friends and colleagues. I've got Sam Jones, who is here, one of the newer staff members at the Visitor Center, and Joe Wheelock, who is one of the less newer staff members at the Visitor Center. And we've got our moderators standing by to answer questions, and we are going to be talking about eclipses today. And I think it'll be a lot of fun. We're also going to be looking at a live view of the sun. And I want to start with just a few slides. As soon as I find my slides, this is one of these things. So we're going to start with a few slides. So here we are. There we are. This is our pretty title page. This is part of the Texas Science Festival, and I think we're the last thing in the Texas Science Festival. But so welcome to those of you who are here for the Texas Science Festival. And if you are not already a subscriber to our YouTube channel, go ahead and click subscribe sometime while you're here, because we would love to have you come back sometime. So eclipse is in the heart of Texas, and we're going to be talking about the sun and about solar eclipses mainly. But we have some things to look at here, some slides, some pictures, and I want to show you where we are. We are here at McDonald Observatory, and I know that some of you have been here before, but maybe not all of you. So let's just, you got to see how to get my slides to move forward. There we go. So here's a beautiful picture of the observatory taken looking from kind of from the west after sunset. And you can see we have our two mountaintops with our research telescopes up there on the right-hand mountain. That's Mount Locke. We've got two white domes that are our older two research telescopes. And on our left-hand mountain, Mount Fulks, we have our silver dome that houses the Hobby Eberly telescope. And let's zoom in a little bit. Oh, here we are. It's daytime now. We're flying into McDonald Observatory on our helicopter. You can still see our two mountains on either side. And in the center of this view is our visitor center. So when you come to visit us, you'll visit the visitor center. And we're both kind of near the visitor center. Sam is in the visitor center. Joe and I are in the old visitor center building because Joe is closer to the solar telescopes, and I am in an area that we call the studio. So that's where we are. So yeah, there we are. There's our visitor center. So do come and visit us. We do daytime programs. We do nighttime programs. It's really best to take a look at our website and see what's available and to make a reservation to ensure that you get what you want. So before we talk about the sun and the moon and the earth, we want to talk about this kind of big, mean word, gravity. And hold on. I have a ball in my hand, and if I just let go of the ball, you all know what would happen, right? You all know what would happen. I let go of the ball goes down onto the floor as it happens. So the ball is gone. So I have a slide. So here's my person standing on the globe, and my person is going to let go of the ball. And what direction is the ball going to go? I bet you know this. The ball is going to go toward the earth. This didn't play my slides the way I wanted it to. So now I have three people standing on the earth, and they're all going to drop their ball. And person number one on the North Pole is going to drop the ball, and it's going to go towards the earth. That's easy. Person number two on the equator is going to drop the ball. And what direction are we going to see the ball go? Is it going to go down towards the bottom of the screen? I hope not. It's going to go, well, let's say it won't go down towards the bottom of the screen. It will go towards the earth. And person number three at the bottom of the globe is going to drop the ball, and it's not going to go down to the floor like my ball did. It's going to go not that way, but toward the earth. And this is something we kind of have in our heads. We know that, but gravity is the attractive force between things that have mass, and the earth has a lot of mass, and so we feel like the earth is attracting all of our things. How about this? How about if we just have one person and he's got one ball and he drops the ball? Or let's go with the ball. And where would the ball go? Down toward the center of the earth and then just keep going? How about that? No, the ball's not going to do that. Because remember, the person standing on the South Pole, when they let go of the ball, it went toward the earth. So I don't expect that the ball is going to leave the screen. It's going to go toward the earth, toward the center of the earth. It's going to bounce back and forth in there, but it's going to come to rest at the center of the earth. So the things that we drop, and now I have a light bulb, we drop them and they go toward the center of the earth, no matter where we are on the earth. Let's change our situation here. I have a baseball and I have a bat, and I'm going to hit the ball. And when we hit, it's going to go a ways, and then it's going to go down toward the center of the earth. And if I hit the ball farther, harder, not just a single, but a double, it's going to go forward farther, and then it's going to go toward the center of the earth. And if I hit the ball even harder, the ball would go forward, farther, and then it would drop toward the center of the earth. But if I had superpowers and I could hit the ball as hard as possible, that ball would go and go and go, and it would keep missing the earth until it went all the way around. And you know what? It would just keep going. And we call that an orbit. So in order to get something into orbit, it has to have a lot of forward velocity, and then it falls toward the center of the earth, but it's missing. It's missing the center of the earth. So can you think of something that's orbiting the earth? Maybe drop into the chat. If you can think of something that's orbiting the earth, drop that into the chat. We like to have a lot of chattiness here. Tell us what's orbiting the earth. Meanwhile, I have another picture. Let's go. So here's a picture. This is a picture taken from lunar orbit, and the moon is one of the things that's orbiting the earth. And so this is kind of a backwards picture. Usually we look at the moon from the earth. But yeah, there's the moon. And here we got a satellite. Yeah, the ball is going to smack you in the back of the head. That's pretty funny. And keep orbiting the earth. If you were, 250,000 miles tall and you had launched the moon forward, the moon would smack you in the back of the head. But fortunately, that doesn't work that way. Okay, so the moon is falling toward the center of the earth. And it's missing. What's the earth doing? Sam, what's the earth doing?
Orbiting around the sun.
Orbiting around. Is it falling?
Well, technically, it's
toward
the sun.
The sun, and it's missing.
Mm-hmm.
Thank goodness. Yes. So the earth is orbiting around the sun, and the moon is orbiting around the earth. But from this viewpoint, it kind of looks like you're sitting on the moon and the earth is in the moon's sky. And if you're sitting on the earth and you see the sun in the earth's sky, it's kind of the same thing, right? And lots of times we sit on the earth and we feel like the sun is orbiting the earth. We know that's incorrect, right? Here, let me mess this up a little bit. Here, we're looking at the sun and the earth and maybe the moon. And this is just an artist's idea, I think. Maybe it's a put together view from Kevin Gill. It's got a satellite view of the earth, and you can see North America at night because the sun is shining on the other side of the earth as the earth falls toward the sun. and misses. Yeah. So the Earth is falling toward the sun, the moon is falling toward the Earth, and they're all missing, and we're all happy about that. So here is a view that shows the moon and the Earth and the moon, and this is really not to scale at all. So please don't think this is how this works. The moon and the Earth are not right next to each other. They're to scale by size, but the moon really should be 30 Earth diameters away from it. So you can't fit those both on one screen without making them kind of tiny. And I've got one of those coming up for you. But you look at this view and you can see which direction the sun is in, right? The sun is off to our left. And it's shining on the left-hand side of the Earth, and it's shining on the left-hand side of the moon. And if you were on the Earth and it was nighttime, so you were on not the sunny side, but the right-hand side of the Earth, and you looked up at the moon, what phase of the moon would you see? Joe, do you want to tell me what phase of the moon you'd see if you were on the night side of the Earth in this picture?
Full.
Full, yeah, because that whole side of the moon that faces us is illuminated. Okay, I might have one more picture here, or I might want to switch. I've got a helper here, and this is some images that we pulled off a NASA website. But here's our helper. We don't know her name. I'm sure she's very nice. And she is showing us one way to learn about the phases of the moon. And she's got a ball on a stick, and the light is shining from the left. You can see that. It's shining on the left-hand side of her ball, and it's also shining on her face because her face is facing the direction of the light. And then in the box, you can see what her view of her ball is. And her view of her ball is it's totally dark because she's looking at the side that's not illuminated. She's looking at the side that we call the dark side. Well, we don't call it the dark side, but it is the side of the ball that isn't illuminated. So what phase of the moon? We call that one new moon. And if she moves the moon, because the moon orbits around the Earth, takes almost a month for the moon to orbit around once. But if she moves the moon a little bit to her left, what she sees is that a smidge of the ball that she's holding is illuminated from her point of view. And then and we can see that the sunlight is still coming in from the left-hand side of this picture. So let's move it a little farther to the left. And now what our student sees is she can see that half of her ball is illuminated. And we call that phase of the moon first quarter because she has moved the moon a quarter of the way around her head. And what was I going to say? She's moved the moon a quarter of the way around her head, and so it's a quarter of the way around. It's the first quarter. If she keeps going, once we're in the phases that we call waxing, so the illuminated portion from our point of view is getting bigger. Here we have waxing gibbous, so it's kind of egg-shaped, and then one more smidge around and we get to full moon. And full moon means that the sun is shining on the moon ball and the illuminated portion is all visible to us. And if we keep going around, then we're going to have the waning phases of the moon where the illuminated portion gets less and less. So let's keep going around to the left. So this is a waning gibbous moon, a last quarter or third quarter moon. Right before that, we missed it. There was a crescent moon in there somewhere, a waning crescent, and then back to new moon. So you can learn about moon phases. And, if I have to think about moon phases, sometimes I just find myself a ball and a light bulb, and I shine the light on the ball, and I'm like, where does it need to be the phase of the moon that I think it should be? Something like that. I really like having a ball to help me with that. Okay, so that's a way to learn about the moon, but this is going to be a video. And before I start the video, let me just tell you what we're seeing. In the center, we have the Earth. And the little thing that's going around the Earth is the moon. And again, the sun is shining from the left. So you can see that the Earth and the moon are casting shadows into space off toward the right. The reason the disk of the moon's orbit is that blue disk is partly light blue and partly dark blue is because the moon's orbit around the Earth is not a perfect, is not perfectly in line with the Earth's orbit around the sun. And so sometimes the moon is above the plane of the Earth's sun, and sometimes it's below. And so that disk is showing you that. And we'll look at it from the side here in a minute. But let's just get this started. I think this will do it. Oh, that didn't do it. Okay, I think. Hold on. I think clicking it with my mouse will do it. I hope this will do it. Nope, that didn't do it. All right. This is supposed to be a video and it's supposed to work. So exciting when everything works, isn't it? All right. Try this mouse. No, it still doesn't work. Okay, then. Now I'm trying to remember what to do next. I want this video to work. Somebody should say something. Joe or Sam, please help me here. Okay, well, hang on a sec. Just please bear with me, and we'll see what we need to do next. Oh, that's what. You guys can talk. Right click, yeah.
Yeah, there are suggestions in the chat. So
I see that.
Yeah.
Everybody's helping. I think I don't know what it. Oh, I know what it is. We'll get there.
Okay.
No luck?
Maybe we'll get there. What?
No luck yet?
Well, give me a moment.
Okay.
Sheesh, guys. Ah.
Cool. Comments. There's just sunspots on the sun today, Joe?
There are sunspots.
There are sunspots.
Yay.
Oh, yeah, plenty.
At my head, yes.
We'll be doing that here soon.
Yep, but let's get everyone excited for it.
I know. I'm so excited to see the sun live. All right. So.
Well, Spiral is suggesting everyone stands on their left foot and pats their head.
Try this. Oh, Judy. Try this again. Okay. I'm almost there, guys. Really. Add
You
this
got
to the stream.
Believe.
See? There it is.
Uh-huh.
And I'm afraid to hit any key because it makes it go away. Ah, this is so fun. All right. Well, the moon goes around the Earth, and the sun makes the moon cast a shadow onto the Earth. I have a video of that too, but I have no idea where it is. So we'll get to it. So maybe this would be a good time to look at the sun live.
I was going to suggest that while you're trying to fix your video.
I'm trying to get my act together.
Right. So, all right. So we may come back to Judy's video here in a few minutes. But anyway, it's a good afternoon. Hope everybody's doing pretty good. We have some nice sunny skies here today. So I'm going to share with you some views of the sun here in a few minutes. Before I do that, I'm going to talk a bit about the sun. And we'll start off here with some safe ways to view the sun. Now, the safest way is to use a telescope with a filter that fits on the very end of a telescope. There are different types of filters, mylar filters and glass filters. Another safe way when using a telescope is to project the image on a piece of white paper or a piece of white cardboard. In the picture here you see that is the eyepiece of the telescope, the big black thing, and the sun is being projected onto a piece of white paper. And that's one of my telescopes. And unfortunately, when I did this that day, there were not any sunspots. So that's the way it sometimes goes. Okay, anyway, moving along here. To view the sun without a telescope, a couple ways. You could use, for instance, a cracker with holes in the cracker, project little images of the sun as shown in the picture on the left-hand side, or you can use what are called eclipse glasses, and you just use those visually without any optical aid. Those are perfectly safe for viewing the sun for that. So some safe ways there to view the sun. One thing you never want to do, though, is use a filter that screws in on the end of an eyepiece. Some cheap telescopes might come with these types of filters, and all these are is a piece of welder's glass. And if you have one of these or know somebody that has one, I recommend you take it out and whack it with a hammer. So don't ever use those types of filters. They can be very dangerous. The concentrated sunlight could cause that welder's glass to heat up and crack. Don't want that to happen. All right, so in a minute, we'll be looking at the sun with telescopes we have here at the observatory. And our solar telescopes, they're located in this structure, just called a roll-off roof observatory, for obvious reasons here. And then we have 3 telescopes for viewing the sun. We have our main telescope, a 6-inch telescope, that allows us to view the sun close up. Then we have smaller telescopes on the main one that allows us to view the sun, kind of a wide-angle view of the sun. And I can control the telescope from pretty much anywhere here. I mean, I'm at my desk here, and the roll-off observatory is just a little ways from here. So our solar telescopes. All right, some facts about the sun. The sun, it is made up mostly of hydrogen, helium, trace amounts of other elements. It has diameter of 865,000 miles, or about 1.4 million kilometers. It's about 93 million miles away from the Earth, or about 150 million kilometers. Temperature of what we call the photosphere, the visible area of the sun, is around 10,000 degrees Fahrenheit, and the core of the sun is around 32 million degrees Fahrenheit. And we estimate the sun to be about 4.5 billion years old. It's considered a middle-aged star. All right, let's see here. We're going to view the sun here in a minute using 2 different types of light. We'll, of course, be using, slide here, visible light that our eyes can, of course, see. We'll also be using what we call hydrogen alpha light. And these hydrogen alpha filters, they block out much of the spectrum as possible, leaving only a very tiny bandwidth through which this hydrogen alpha light can pass here. All right, let's see here. Yeah, so here's our bandwidth here of hydrogen alpha light. All right, so when we view the sun here in a bit, you'll notice dark areas on the sun. And what are those dark areas called? Write that in the chat if you can remember what those dark areas on the sun are called. Do we have anybody writing? It could be a delay here in the chat. No.
Okay.
Okay. What
Joe,
do they call, Judy?
is that live?
That's not live.
Oh,
It will be.
those are called dark areas on the sun.
Right. Better yet, sunspots. Yeah.
Those are called
Sunspots,
sunspots.
they appear dark because they're cooler than the rest of the sun. There we go, showing up now. And I use cool as a relative term. A temperature of sunspots average around 5,000 degrees Fahrenheit, or maybe about 3,400 degrees Celsius. And the next, let me show you a close-up view of sunspots. Sunspots have a darker center called the umbra and a lighter outer area, the penumbra. Latin words meaning shadow. When people first looked at the sun, they thought there were shadows on the sun. And you'll hear these terms, umbra and penumbra, a little bit later on during the program. Now, the color picture of the kind of grainy appearance, that's called granulation caused by convection currents within the sun. In fact, I want to show you a video of the sun here. This video was taken, whoops, back up here. I don't know why I did that. Go back here. There we go. This video was taken in December of 2019 by a 4-meter telescope, the world's largest solar telescope here. So, and in the next picture, you'll get a better idea about the size of the individual granules, about the size of Texas. Now, the next, we will see a picture of the or video here of the granulation close up, kind of behaving like a pot of boiling water. Then finally, an amazing close-up of video of these convective cells on the sun, these Texas-sized convective cells. All right, let's see here. What's next?
Hey, Joe.
Yes.
What happens when you fall into a sunspot?
What happens when you fall into a sunspot?
Yeah.
Well, they're really hot. They're,
Yeah.
actually, they are really hot, 5,000 degrees Fahrenheit. So I guess you'd burn up.
You'd burn, but the question is, if you were able to survive a temperature the same as the Earth's core, then what would happen?
I really don't know.
Because we're not.
Right, I really don't know.
I don't know what the temperature of the Earth's core is
Yeah,
either.
I can't recall that off the top of my head. So.
Yeah.
Anyway, besides sunspots, we might see features like this. These are called solar prominences. This is a time-lapse image taken over a period of a couple of hours with one of our telescopes. And when viewed face on, they are called solar filaments. And they're dark because they're cooler than the rest of the sun. And violent eruptions on the sun, these are called solar flares. And they're bright because they're hotter than the rest of the sun. All right, so let's go ahead and view the sun with our telescopes. Let me find that here.
Hey, Joe, before we get to that, we had a great question about working with students 1st through 3rd grade. Had the misconception that the sun is getting hotter. How would you address that?
Misconception that the sun is getting hotter? It is not. It is not getting hotter. That's how I would address that. Although the sun in about 500 million to a billion years, it will brighten by 10%. That will happen. That 10% brightening will be enough to boil away the oceans, make it bad for us on the Earth.
So I think we could look at the spectrum of sunlight and look at the light curve and say
exactly
it's peaking at the same place it has been peaking at.
Exactly.
Which tells us the temperature. And I think that's probably what I would do to show students some evidence that the sun's not getting hotter.
Sure. And the sun will eventually expand into a red giant star engulfing the Mercury, Venus, and the Earth. And that's 5 billion years, nothing to worry about. But let's have a look at our nearest star here, the sun. So give me a second here, and I will find the sun. Here it is. All right, so here we have a live view of the sun today with one of our smaller telescopes. We can see a number of sunspots in this view today. Now, right now, we have a lot of activity happening because once every 11 years, the sun reaches a peak of activity, hovers there for a couple of years, then it goes back down. We call this solar maximum, and we are heading toward the next solar maximum here in just a couple of years. Now, the biggest sunspots you can see in this view, like this one here, perhaps maybe 3 times, 4 times or so the size of the Earth. So that's a visible light image of the sun. And I don't have a way to show you the sun itself without you seeing my controls. So you're going to see what happens here behind the curtain while I do this here. So give me a second here, and I'm going to switch our view to hydrogen alpha light. And this will be a close-up view of the sun. That's kind of big there. Let's go ahead and shrink that down here. Go to 75% view. There we go. All right, so now in our hydrogen alpha light view of the sun, we can see a number of the solar filaments that I talked about, and a few sunspots are visible too. And I think I saw a bird fly in front of the telescope. I saw something move across the sun there. But the sun, now it does, rotate on its axis. Different parts of the sun rotate at different speeds. The equator rotates faster than the poles. And it takes the sun about a month to rotate on its axis. We have a fancy name for this difference in rotation. We call this differential rotation. And the sun has a very powerful magnetic field. So as the sun rotates on its axis, the magnetic field lines, they kind of twist up like a rope. And the areas where they twist up is where we have activity, like we can see that happens on the sun. Another bird. So, all right, so next we're going to view the sun with our main telescope here. And this will be a close-up view of the sun. I hit the wrong one. We just saw that. Let's try the other one here. Let's try the right telescope. That was this one. I'll get it one of these days. Whoa, hold on. We'll turn that down. The red you saw, that's going to affect the camera to help us kind of calibrate things on the telescope. Let's see here. Here's a close-up view of the sun. A little fuzzy today, but let's move the telescope here. Not moving the sun. And we have some sunspots. Here's a nice sunspot. And you can see that umbra and penumbra I talked about.
We got a few great questions in the chat about sunspots, Joe.
All right. I didn't see those questions here.
Do sunspots stay in the same place or do they change?
Do sunspots stay in the same place or do they change? No, they don't stay in the same place. They do change. They're carried along the sun as it rotates on its axis. Yeah. So let's go back to our live view here. Let's have a look at what we call the limb of the sun. not the edge, the limb. And what I'm going to do to get a better view of this is paint the sun red with our software. So we have a prominence you can see right here. Before I talk about that, this fuzzy area you might notice on the sun, that is called the spicule layer. These are rising jets of gas. They rise up at about 12 miles per second, disperse within 10 to 15 minutes. Now, how thick do you think that spicule layer might be? If you think you might know the answer, stick that somewhere in the chat, that little fuzzy edge. Let's see if we have any answers here in a second. I think we have a delay on our chat answers before we get them. So, but just think about that for a minute. Let's see if we have any answers.
Well, Joe, while you're thinking, what causes sunspots to form?
Sunspots are caused by the sun's powerful magnetic field. You have hot material welling up from the side of the sun, being disrupted by these magnetic fields on the sun. All right, I'm not seeing any answers to my question.
Oh,
So there we go. 10,000 miles. 5,000 is very close. That's about half the size of the Earth. Yes, half or so the size of the Earth. All right, so now we know the answer to that. Let's travel around the sun today. We have this prominence here. That's extending maybe 25,000 miles away from the sun. But let's travel around the sun without getting burned. Moving the telescope here. There's here we go. Oh, here's a nice one. Let me do some camera fiddling and see if we can improve that view a bit. Yes, and glare. There we go. That's a little better there. And so this extends, you can see up here, oh, I don't know, maybe 50,000 miles away from the sun, somewhere around there. Give or take a mile or two. Let's see what else we have happening. Oops, here we go. Here's a better one, bigger one. Let's mess with this here. There we go. So you can see this one's kind of looping around here, you know, following the sun's magnetic field. Nice one there. Little activity there. It's been pretty active recently. There's a little one there. I say little. You could easily fit the Earth inside of that with room to spare. It's compared to the sun, not very big, but here's another one. Nice prominence there. And anything else? Little activity there. And we are just about back where, here we go, back where we started with our nice prominences there. All right, one more thing before we go to our next topic. I want to share with you real quick. If you're still fuzzy about how activity on the sun behaves, let me share with you a video here. Where'd it go? Here it is. So here we have a, this is a discard that. Plastic cube, we're shaking up the cube. Inside the cube are some iron filings. And next you will see a magnet, a bar magnet. And notice how the filings are following the field lines of the bar magnet. So that might help you better understand how activity on the sun behaves. All right, so I hope you enjoyed these live views today of the sun, and we'll head to our next topic then. Thank you for watching for that.
Okay, well, I have a couple of really cool videos I'd like to share.
That will work?
Yes,
I'll mute myself
yes,
now.
I have a couple of really cool videos to share that show eclipses and show how solar eclipses happen when the sun and the moon and the earth are all lined up. So let's start with this one. This one here, we're looking at the moon and looking kind of from the direction of the sun, and you can see that the moon is casting sort of a little tiny black shadow on the earth. And as the moon orbits the earth and the earth turns, you can see that that shadow moves across the earth. So the little tiny sharp black shadow, that's the part of the solar eclipse that we call the umbra. And then you see this other part of the shadow that is less dark, and that part is called the penumbra. Have you heard those words before? I hope you have, because it just means a shadow and the part next to the shadow. So as the moon and the earth change position, the moon orbits the earth and the earth turns, the shadow moves across the earth. And so we do find pathways across the earth for eclipse paths. And what this video showed was the solar eclipse of 2017, which was a really huge one. And I know some of you saw that in person. But now I'm going to share my screen and show you my other video. And I found it, and it's going to work this time, I think. And this is one. All right. It's not my screen. I think I have to move this. All right, here it is. There we go. Okay. Here it is. Here's the video. So this one shows the sun and light is coming in from the left, and the moon is down near the bottom of the screen right now. The earth is in the center, and the moon's orbit around the earth. There's two things to notice about it. One is the moon's orbit around the earth is not a perfect circle. So the blue circle is a nice circle, but the orbital path is a little bit off of that. And I'll bet you've probably heard that sometimes we have a supermoon. Supermoon just means on its elliptical path around the earth, the moon at full moon is a little closer to the earth, so it appears slightly larger in the sky. And sometimes we just have a regular full moon that's a little bit smaller. So let's play the video. I think this will work. Here we go. So the moon is going around the earth, and you can see the shadow is being cast as the moon goes around the earth. Now let's look at this from the side, because the moon's orbit is not in line with the Earth's sun. And so sometimes the moon's orbit is below that plane, and sometimes it's above, and sometimes it hits that plane right on, and that's when we get an eclipse. So we don't get a solar eclipse every time we get a new moon. We only get a solar eclipse every time we get a new moon, and the orbital plane is at the same orbital plane as the Earth-Sun orbital plane. It's a little bit complicated, but it does work, and it means that we get solar eclipses pretty regularly, and we can predict them. And you can see, and this is to scale with the size of the Earth and the moon. So the sun is very far off to the left, and that shadow path across the Earth is very teeny. It's a little tiny spot on the Earth. So the path across the Earth of an eclipse is a pretty tiny thing too. Okay, now I want to talk about one more thing. And first I want to find just get this out of here. So you may be saying the moon is tiny and the earth is bigger. And this is true. And the sun is way bigger. So sitting behind Sam is a model of the sun. And that model of the sun, the things across the equator of the sun are half-inch blue dots. And those half-inch blue dots are the scaled size of the earth compared to the sun. The sun is way bigger than the earth, and the earth is way bigger than the moon. So the sun is way, way bigger than the moon. Now, here's my question. How can something tiny like the moon cover up something big like the sun? Good question, right? So here's something you can all try. Try it right now. Hold your thumb with one eye. Use one eye. Hold your thumb so you're covering up, I don't know, my face, the screen, some part of the screen. Just cover it up. Now, if I were going to do my face, I'd have to hold it right next to the screen. That won't work. I'm just going to cover up the whole screen with my thumb. Okay. My thumb is way littler than my screen, but I'm covering it up because it's closer to me. Now, sometimes the moon's a little farther from the earth. So sometimes I'm covering up most of the picture here. But if I move my thumb just a little farther away, I can see more of what's behind it. So you can do this with your friend. You can cover up their head and then not quite cover up their head as you move your thumb farther away from you. Or you can do it with a picture on the wall, or there's that light switch. I have it covered up and I move my thumb a little farther away and I'm not quite covering it up. So it's distance and perspective. And yes, the sun is 400 times larger than the moon, and the moon is 400 times closer. And those are rough, but they work. And so now I want to talk about types of eclipses, and that is this. So partial eclipse is what you get most of the time during a solar eclipse event. Most of the time, what you see is a partial eclipse. And a partial eclipse means the moon is partially covering up the sun. The other thing about a partial eclipse is you don't have to be in the fancy path of totality to see a partial eclipse, and they're pretty interesting. So, what's the best kind of eclipse to see? Of course, not an annular. Annular is good too. But let's do a total solar eclipse. A total solar eclipse means the moon totally covers up the sun. And then what you can see around the sun is the corona and maybe some other things that we'll talk about in a little bit. A special case is the annular solar eclipse. And an annular solar eclipse happens when the moon is on its farther part of its orbit around the Earth. So it appears a little smaller in the sky. So your thumb is farther away from you, and you can see your friend's face, head, hair around your thumb that you were blocking with your thumb, right? So an annular solar eclipse is that special case where part of the sun is blocked, but the moon is centered on the sun. And annulus just means a ring, so you get a ring-shaped sun. Yes, it's very cool. Now, you're probably all saying, but there's one other kind of eclipse that we haven't talked about, and that's the lunar eclipse. And this is true because we're looking forward to solar eclipses, but a lunar eclipse is another instance of where the sun and the earth and the moon are all in a line. And in this case, let's see. I got to get this right. The sun shines on the earth casts a shadow onto the moon. And so the moon becomes dark. And we name the eclipses out of the thing that gets darker. So a solar eclipse, we're looking at the sun, it gets darker. A lunar eclipse, we're looking at the moon, it gets darker. So a lunar eclipse is the other kind of eclipse. And usually that means also that the sun and the moon and the earth are all in that same plane, which happens however often it happens, twice a year. But they all also have to happen at the right phase of the moon to get a lunar eclipse. And lunar eclipses are awesome because you can see in this picture, the moon looks red. And the moon looks red because sunlight passes through the Earth's atmosphere, and some of that filtered light, red light, shines on the moon, and it looks very cool. Please don't call it a blood moon. We try not to do the superstitious stuff here. All right. So those are types of eclipses. Now, I think it's Sam's turn to talk. What you got, Sam?
All right. Well, we have what to look for during an eclipse, which is fun. So, what changes do you think might happen to the environment during an eclipse? Drop it down in the chat. I'm excited to see these answers. Anyone want to answer any questions? How often does an annular eclipse happen? Do you know that one? No? Well, all right.
Joe, you're muted.
My mic was muted. Right. Sorry about that. You might see some annular eclipses perhaps every somewhere on the Earth, maybe one, maybe a couple every decade, perhaps on the average.
Cool. All right. Birds get quiet. Yeah, I like that. That's cool. Anyone else? The environment goes crazy and they think it's night. Well, some animals do think it's night. Temperature drops. All right. Well, while we go through our eclipses, try to look for temperature changes. So we suggest checking the temperature before, during, and after to see any changes or fluctuations that occur during the eclipse's progression. We also suggest animal behavior. So keeping a check of the animals that you hear and the animals that you don't. Some animals that are awake during the day will go quiet at the totality of the eclipse and vice versa. So we got that to look forward to. Bright stars and planets appear. Wow, y'all are doing so great. We also have the sun's corona. The corona will be visible during the total solar eclipse. And we also have the corona as well. So it's the web-like area around the sun. Also suggest looking for shadow bands. So they appear on the Earth, on the ground. It's a thin strip of sunlight that we can see. And NASA says that they are thin, wavy lines of alternating light and dark that can be seen moving in parallel plane color surfaces, so a white surface or any regular plane surfaces. And I have seen a couple of people kind of compare it to like looking through a pool on a sunny day, how that light always waves and changes. And then, yeah, planets and stars. Some planets and stars may be visible during the eclipse, so keep an eye out for those as the eclipse happens. All right. I think that's it for me.
And then Ludivina says, hold on, I'm putting this on. I saw the shadow approaching. It looked like a dark band of rain.
Ooh, cool.
Ooh. So if you're especially if you're up on a hill or something, as you can see that shadow approaching. And that's kind of crazy too. Yeah. Yeah, you guys are really good at this.
Yeah.
So you should drop in the chat, everybody, if you have seen a total solar eclipse. Sam, have you?
I have not.
Is one coming through your hometown?
There is one going through my hometown. It's literally, my house is here and it's just up the street. I'm so excited.
Joe, have you?
Yep, I've seen a total eclipse. I've seen a couple of annulars and many partials, a bunch of lunar eclipses. Yeah, I've seen a few.
Yeah. So the important thing with viewing eclipses and waiting for eclipses is to make sure your eyes are protected until totality. So if you have an annular eclipse, that doesn't count as totality. The the sun is the annular eclipse that we're looking forward to in October. The sun's going to be about 90% covered, which means 10% of the sunlight is still enough to hurt your eyes. Okay, somebody was in Kearney, Nebraska. A total lunar eclipse. That's good. That's a start. There's a total solar eclipse coming. So, yeah. Place a white cloth on the ground to possibly catch the shadow bands. And I saw a video where they just used their white vehicle. And they say to catch the shadow bands, one thing to do is to take a video, because it's hard to see it because in a still picture, because it's a moving thing. So somebody asked about hybrid solar eclipses. It was and a hybrid solar eclipse is just a rare example of an eclipse that happens. It changes as the moon's shadow moves across the earth. So it's partial some places, and I don't understand a hybrid solar eclipse.
I think it's annular in some places
Annular
and
in some-
total in others.
Okay.
So it has to do with, I guess, the distance of the moon.
When it's just at that.
Yeah. Just at that the wrong spot where maybe it'll be total, maybe it'll be annular.
So I'm seeing comments like this one. When is the next total eclipse expected to happen? I think it's time to share some maps, because the reason we're talking about eclipses is that there are two of them that are headed our direction if we're in Texas. This is Texas Science Festival, so we should be in Texas. And this is a nice map, but let's look up close at the Texas map, and that is the next slide. So there is. This is October 8th. It's coming from the northwest through New Mexico, down through Midland, Odessa, Texas, down through, there's Kerrville, and this is very tiny on my screen, much of San Antonio, and out through Corpus Christi. This is an annular solar eclipse, and the annular solar eclipse happens on October 14th, which is a Saturday. And if you're in the center of this path, then you'll get a really great view of that circle of light. Be sure you protect your vision, or do something fun like buy a box of crackers and look through them. Then on April 8th, 2024, there is a total solar eclipse whose path comes into Texas through about I forget the name of the town. A town on the border, and then comes through Kerrville again.
Del
and
Rio.
Part of what?
Del Rio.
No, that wasn't the one I was thinking
Wasn't
of.
it? Okay.
But
never mind.
it's okay. It's okay. So Austin, and staying, it's kind of most of Austin, much of Dallas, Fort Worth, and Waco is right in the middle. And then it goes on up, and it goes up and up and up through the northeast part of the U.S., including Ohio, where some of our friends live, and off into Maine and Canada. And that is a total solar eclipse, and that has a nice long period of totality. It's about 4 minutes in some spots. And Texas is a wonderful place to be to observe eclipses because we have nice clear weather. And do any of you live in either of these paths? You could tell us.
Oh, someone does.
What?
Rebecca Danielle. She'll be in the path of both.
Wow.
That's so awesome.
That's so awesome. That's so lucky. Yeah, Eagle Pass. That's what I meant.
Eagle Pass, yeah.
Yes, thank you. Please back up one slide. Just for you, Patricia. Yeah, Texas is the best. I don't know. Yeah, Corpus gets 5 minutes of the annular eclipse. So, yeah, you want to have eclipse viewers or something, but yeah. It looks like Texas is in a car seat. I'm not sure what that means, but I'm not going to worry about it. Seatbelts?
Yeah.
Yes. Okay, got it. Yeah, Kerrville. That's the place to be, I think. If you live in those places, think hard about what you're going to do about the renting out your driveway. No, traffic, crowds, etc. So there's lots of things. Big Spring, Texas. I think Big Spring is in the path of the annular eclipse.
Looks like it.
Yeah.
I think it's a little sad we're here at the observatory and we're not in the line of either.
Oh, no,
Yes,
really.
I'm going to go forward one. Yeah. The observatory is over here. We get a partial eclipse both times, but not a total. And so there'll be much politicking happening about who gets to go. But that's okay. That's okay. It does. The two lines go across Texas and make it look like a seatbelt. Yes. All right. Okay. So here's what we think. We think the best thing to do is to see a total eclipse in person. So if you possibly can, get into the path of the total solar eclipse on April 8th, 2024. Is Austin in line for the annular? No, it's out by just a little bit. Austin's over here, the path of the annular. Yeah, it's a short drive to get there, though. And really, the total is the really great one. But yeah, go see the eclipse in person. What else do we need to tell everybody before we're done?
Make your plans now if you haven't already done so.
Make your plans now.
Start planning. I'm sure there are already hotels and things that are booked up.
Mm-hmm.
So,
Yep.
yes.
Yep. So if you think you want to purchase eclipse viewers, please buy them from the reputable dealers. And they will have the correct markings on them that say that they're, and we don't have any with us to show you. But yeah, expect crazy traffic, but just find something to do for the next hour after the total eclipse is over. Then you get a partial eclipse for a while. So, hey, it'll be fun. Yep, crazy traffic, and you shouldn't regret it. That's right. Anyway, if you haven't done so, we would love it if you would subscribe to our channel. And thank you so much for joining us. I've got one more slide, and I think it's this next one, unless I messed up again. Let me just see. Yes, this is the one that says you can join the Friends of McDonald Observatory. You can find us online at mcdonaldobservatory.org or stardate.org. Who are the reputable places have the I can't tell you this stuff. I don't have that right now. We will put that information in the notes because it's important to get the right things and make sure that they don't have pinholes and they won't damage your vision. But I don't have that in my head, so it's got to go into the show notes. So check back in a few days, and that link should be there for you. Anyway, come and see us again. Come and visit us, and do go see an eclipse. Thanks, everybody. Bye.